Welcome back. Today we are going to discuss about the Pascal's triangle and binomial theorem. First, let's make an introduction to what a binomial theorem is all about. If I have the expression A plus B, this expression is a binomial because we have two terms, A and B. Similarly, if I have the expression 2A plus 3B, this is also a binomial for the fact that we have two terms, 2A and 3B. Now, if this expression should exist in powers, let's say A plus B to the power 5. Trying to expand this is what we call binomial expansion. From your own lessons, if you have, for example, A plus B to the power 2, this is also a binomial because you have two terms. But how do you expand this? It is simple because it means A plus B multiplied by A plus B. So how do you do that? Well, you take this A, multiply it with A plus B, then take the B and multiply it with A plus B again. With that, you will have A into A plus B plus B into A plus B. That will be A squared plus AB plus AB plus B squared. So we'll finally have A squared plus 2AB plus B squared. So this is relatively simple. But in circumstances where you have, let's say, A plus B to the power 6, which means you're going to have A plus B multiplied by 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 A plus B. So that is what power 6 means. A plus B multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. So this work will be very, very painful because it is going to be a frustrating experience for you. So that is where the application of Pascal's triangle is important, because when we use the Pascal's triangle, we can use the coefficients and it will help us to reach the answer in a relatively short period. So we will now move on to give an introduction to the Pascal's triangle. Now, you will first have a number, let's say 1. Then you have 1, 1. And what you do next is you will be adding the numbers, all right? And your ends will always be 1. So let's say 1 plus 1 is 2. So the ends will be 1 and 1. Then I come again to this step. 1 plus 2 is 3. 2 plus 1 is 3. So the ends will be 1, 1. Moving on, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then the ends will be 1, 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Then the ends will be 1, 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then the ends will be 1, 1. And this sequence will continue. So if you look at the shape that it comes to, it depicts a triangle, and that is why it is called Pascal's triangle. But what is important here is the application. How do we use the Pascal's triangle to expand problems that are given to us? Let's say if I have a plus b to the power 2, from the Pascal's triangle, I have power 2. So I will ask myself, where do you have 2 in Pascal's triangle appearing in the second position? This is the first, this is the second. So you have 2 here. So it means the coefficients that we are going to use for this expression will be 1, 2, 1. So let's say is a plus b to the power 5. The coefficients that I'm going to use is, because I have power 5, I will go to the Pascal's triangle and see where I have 5 in the second position. That is this one. So the coefficients that I'm going to use will be 1, 5, 10, 10, 5, 1. You get that? So let's move on to solve problems, okay? So let's say we have a problem here, a plus b to the power 3, using the Pascal's triangle. The power is 3, so I will draw my Pascal's triangle and see where I will have power 3 in the second position. We will have 1, 1, 1, then that is 2, 1, 1, then I'll have 3, 3, 1, 1. So because I have 3 in the second position, the coefficients that I have to use will be this, okay? That is 1, 3, 3, 1. If I write that, I'll have 1, 3, 3, 1. Then what do I have to do? I will bring in the binomials, which are a and b. So that will be a multiplied by b, a multiplied by b, a multiplied by b, a multiplied by b. So that will be plus, plus, plus. Then among the rules when dealing with binomial theorem, one of the terms have to go in descending powers and the other will go in ascending power. So the maximum power is 3. So if one has to go in descending power, let's say a will go in descending power, it will start from 3 going to 0. So the other one will go in ascending power starting from 0 going to 3. That is to say, we will have a as 3, then to the power 2, then to the power 1, then to the power 0. So what of b? B will ascend from 0, 1, 2, 3. Okay? And bear in mind that for any term that you have here, the sum of the powers must be equal to the power that is given. So 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is 3. Okay? Now, moving on, for this expression, we have 1 into a to the power 3 into b to the power 0. Anything to the power 0 is equal to 1. So we're going to have 1 times a to the power 3 times 1. So what will that give you? That will be just a to the power 3. So we are going to replace a to the power 3 in the place of this expression. That is a to the power 3 plus So for this expression here, 3 into a square into b to the power 1, that is the same as 3 into a squared. Any letter or any number to the power 1 is the same as that letter or that number. So b to the power 1 is just b. So which means we're going to have 3a square b. That is what we need to replace here. So that is 3a square b. Okay. Now for this expression, 3 into a to the power 1, b to the power 2, that is 3 into a to the power 1 is just a, into b to the power 2 is just b squared. So we're going to have 3ab squared. That is what we can replace here, 3ab squared. For this expression, 1 into a to the power 0, b to the power 3 is the same as 1 into anything to the power 0 is 1. So a to the power 0 will be 1 into b to the power 3. So if we should expand this, 1 times 1 times b to the power 3 is just b to the power 3. That is what I am going to replace here. And that answers the question. So the answer is a cubed plus 3a square b plus 3ab squared plus b to the power 3. Expand 3a minus 2b to the power 5. So if we should establish our Pascal's triangle, we'll have 1, 1, 1. This is 2, 1, 1. Then we have 3, 3, 1, 1. We have 4, 6, 4, 1, 1. Then we'll have 5. We'll have 10, 10, 5, 1, 1. So because we have 5 in the second place and the power is 5, so this is the coefficients that I need to use. Okay, 1, 5, 10, 10, 5, 1. So using the coefficients 1, 5, 10, 10, 5, 1, we're going to multiply this with the binomials that we have. We have 3a and minus 2b. So that is going to be 1 into 3a into minus 2b, 5 into 3a into minus 2b, 10 into 3a into minus 2b, another 10 into 3a into minus 2b, another 5 into 3a into minus 2b, then another 1 into 3a into minus 2b. Then what do? We add. Okay, we add. Then one of the powers have to go in descending order, while the other will go in ascending order. Since the highest power is 5, let's say 3a goes in descending order, so that will be 5, 4, 3, 2, 1, 0. And let minus 2b goes in ascending order, so it will start from 0, 1, 2, 3, 4, and 5. Okay, so for this expression, 1 into 3a to the power 5 into minus 2b to the power 0. That is going to be 1 into 3 to the power 5 is 243. A to the power 5 is a to the power 5. Okay? Then into this whole expression minus 2b all to the power 0. We say that anything to the power 0 is 1. So it means we're going to have just 1 times 243 a to the power 5 times 1. So that is just 243 a to the power 5. And that is what we need to write in this place. Okay? Let's write that. 243 a to the power 5. Okay? So for this expression, 5 into 3a to the power 4 into minus 2b to the power 1, that will be 5 into 3 to the power 4 is 81, and a to the power 4 is just a to the power 4. Then into this whole expression is to the power 1, and we said anything to the power 1 is just the same as that thing. So minus 2b to the power 1 will just be minus 2b. So if we multiply, we're going to have 5 times 81 times minus 2. 5 times 81 times minus 2, we will get minus 810 a to the power 4b. And that is what we have to substitute here. So it means we cannot have a positive here, but a negative. Okay? So that is negative 810 a to the power 4b. For this expression, we have 10 into 3a to the power 3 into minus 2b to the power 2. So we're going to have 10 into 3 to the power 3 is 27. A to the power 3 is just a to the power 3 into minus 2 to the power 2 is the same as having minus 2 squared. So that is going to be a positive 4. All right? So which means we're going to have 4, and b to the power 2 is just b to the power 2. So if we should multiply this, we'll have 10 times 27 times 4. What will that give us? 10 times 27 times 4 is 1080 a to the power 3 b to the power 2. Okay, so it's a positive value, so that will be plus 1080 a to the power 3 b to the power 2. So for this expression, which is 10 into 3a to the power 2 into minus 2b to the power 3, that is the same as 10 into 3 to the power 2 is 9, a to the power 2 is just a to the power 2, into minus 2 all to the power 3 is minus 8. Okay, then you'll have b to the power 3. So if I multiply 10 times 9 times minus 8, I will have minus 720 a to the power 2 b to the power 3. So that is a negative. So we'll have minus 720 a to the power 2 b to the power 3. So moving on to this expression here, which is 5 into 3a to the power 1 into minus 2b to the power 4, that is the same as 5 into anything to the power 1 is just that. So we're going to have 3a. Okay? Then moving on here, minus 2 to the power 4 is 16. Then b to the power 4 is just b to the power 4. So what do? We multiply the numbers. 5 times 3 times 16. 5 times 3 times 16 will have 240. So that will be 240a b to the power 4. Okay, it's a positive number, so we will add it. So it will be plus 240a b to the power 4. So moving on to this expression, which is 1 into 3a to the power 0 into minus 2b to the power 5. Then that is just 1 into anything to the power 0 is just 1. So 3a to the power 0 will be 1 into minus 2 to the power 5 is minus 32. And b to the power 5 is just b to the power 5. So if I multiply, I will have negative 32b to the power 5. And that is what I have to indicate here, negative 32b to the power 5. All right. So if I should just minimize this, you will see that this is the answer that we will have. The answer is this. Okay? Moving on. So let's say we have this problem 2a minus 3b to the power 4. How do we expand this? Let's try to draw our triangle. We have 1, 1, 1, 2, 1, 1. This is 3, 3, 1, 1. This is 4, 6, 4, 1, 1. So I have the power 4 in the second position. So which means the coefficients that I am going to use are 1, 4, 6, 4, 1. Okay? 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Then now I have to bring in the binomials 2a minus 3b. 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 Okay? 2a minus 3b. Then what do? Since it's to the power 4, one of them have to go in descending order. So from 4, then to 3, 2, 1, 0. And the other one will go in ascending order. So that will be 0, 1, 2, 3, 4. So for this expression, we have 1 into 2a to the power 4 minus 3b to the power 0. What will we have? That is 1 into 2 to the power 4 is 16. Then we have a to the power 4 into anything to the power 0 will be 1. So it means we will have 16a to the power 4. So it means we will have 16a to the power 4. Okay, let me write that. So that is 16a to the power 4. Okay. So for this expression here, 4 into 2a to the power 3 into minus 3b to the power 1, that is 4 into 2 to the power 3 is 8, a to the power 3, then into anything to the power 1 is the same as that thing, so minus 3b to the power 1 is just minus 3b. We're going to have minus 3b. So if you multiply 4 by 8 by minus 3, you'll have minus 96 a to the power 3 b. We're going to have a negative number. So that is minus 96 a to the power 3 b. So for this expression, we have 6 into 2a to the power 2 into minus 3b to the power 2. That is 6 into 2 to the power 2 is 4, a to the power 2, into minus 3 squared is the same as minus 3 all in bracket to the power 2. That is 9. So we'll have 9 b to the power 2 is b squared. So if we should multiply 6 by 4 by 9, we'll have 216 a to the power 2 b to the power 2. Okay, so because it is a positive value, so that will be plus 216 a to the power 2 b to the power 2. Moving on, for this expression here, which is 4 into 2a to the power 1 minus 3b to the power 3, that will be 4 into any expression to the power 1 is the same as that expression, so we'll have 2a into minus 3 to the power 3, that will be minus 3 in bracket to the power 3, you'll have minus 27, so that is minus 27, and b to the power 3 is just b to the power 3. So what do we have? We'll have 4 times 2 times minus 27. 4 times 2 times minus 27 is minus 216. So that is minus 216 a b to the power 3. Okay, so because it is minus, so that will be minus 216 a b to the power 3. And finally, for this expression, 1 into 2a to the power 0 minus 3b to the power 4, that is 1 into 2a to the power 0 is just 1. Anything to the power 0 is 1. Then into minus 3 all to the power 4 is 81. So that will be positive 81. And b to the power 4 is just b to the power 4. So we'll have 1 times 1 times 81b to the power 4, which is just 81b to the power 4. Okay, so it's a positive value, so we're going to add, so that will be plus 81b to the power 4. And that answers the final question. So what do we have? We'll have this as the answer. when we expand that binomial. Now, let's quickly describe terms and coefficients. Term means the whole expression, and the coefficient is the number. So this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. So the second term is minus 96a to the power 3b. The fourth term is minus 216a b to the power 3. But the coefficient of the second term is just minus 96. The coefficient of the third term is positive 216. And the coefficient of the fifth term is positive 81. So sometimes you can be asked to state the term and the coefficient. Okay? So remember what are terms and what are coefficients. See you in the next video. Thank you very much for watching this video. If this is the first time of visiting this channel, please subscribe to the channel. Do not forget to like and share our videos.